Hey guys, it's Solbyte, and today we're going to be going over polymorphism. Now, polymorphism is a pretty big topic in object-oriented programming. It's a very important topic, but it's also to me, it's a very cool topic because of just the amount of functionality and like it really just adds a really powerful tool to your tool set whenever you start making projects. Especially as they become a lot bigger and you know a lot more robust. So yeah, we're gonna go over polymorphism. So by its definition, polymorphism is basically a way that we can manage derived objects using base class pointers, pointers of the base class. All right, and if that does sound confusing, it's because it's kind of a confusing topic, but just try to stick with me, and I'll show you guys some examples. Before that, I do want to kind of show you guys a little bit of our code here just right before we get started. That way you guys kind of understand what we're going to be doing. So I have a lot of these to-dos here. Where we are picking up from my last video where I covered abstraction, and during that we created a base class character, and then we created two derived classes of knight and healer. And yeah, we went over abstraction and how we can use virtual functions, pure virtual functions, or just a normal virtual function, to implement different functionality depending on the derived class. Today we're kind of going to be picking up where we left off, but I did add some things. For instance, I kind of added some attributes up here that are protected, including the name of a character and their HP, otherwise known as their health. These are protected in the access modifier, which if you remember is basically like hiding the attributes, however still letting them be derived into the derived classes. So that means that knight and healer both have name and HP attributes derived into them. However, if we try to, down here, if we try to access Mary's health or Mary's HP, it's not going to let us in any way. So that's kind of what protected is. If you guys didn't see my video when I went over the access modifiers and when I went over inheritance, which is when I covered what the protected access modifier is, please go back and check that out, or go and see another video about it. Pretty important topic. Just try to make sure you understand it. And then we have a constructor here that just takes in the name and the HP and then assigns the name attribute to the name parameter, and same thing for the HP. So that's kind of what this constructor is right here. I didn't create a default constructor. I just, I want to show you guys what I need to show you guys. I'm aware this video might be a little bit longer than most of my other ones. So, I want to kind of get through and make sure that you guys see the important bits of polymorphism and not waste any time. So we have a get name and a get HP, which are getters. I even added the const keyword, which you guys might already be familiar with. It's a pretty basic topic. It just means that we're not changing HP. We're not changing any sort of attributes or anything about the object. We're just returning a value, or it's a constant method. It's not going to really change anything. So and then I also added a print info, which will be really easy for us to implement later down the line when we need to implement more of the main functionality for the program. So just kind of prints the name and prints its respected HP. So yeah, and then I have these comments here stating that we will implement a take damage method for each and every one of these. And for this one, it will be a virtual function. And for these, we will override that virtual function with unique functionality depending on if it's a knight or a healer. And then yeah, for these derived classes, we have the constructor using the same constructor for the character. That way it assigns the name and the HP the same way that the character constructor does up here in the base class. So that's good. And yeah, that's kind of all you really need to know right now. We are, of course, inheriting from the base class character for the knight and the healer. So let's kind of go over what polymorphism is. And polymorphism basically requires pointers and references to be used. Okay, so if you guys don't know a lot about pointers or references, or maybe you are a little fuzzy in that area, I do recommend making sure that you guys know that before this, because it will get kind of complex if you don't already know about pointers and references, and how they relate to memory addresses, and how they work in general. So make sure to be brushed up on that before we dive into this. So yeah. All right, so let's go ahead and get started. So we're going to create a base pointer. So it'll be a pointer of the type character. All right, if I can spell character, I don't know if I can. There we go. So pointer of the base type, or sorry, a pointer of the base type character. So we'll just name it C pointer, and we will assign it. So I created a knight up here named Cedric, and I created a healer named Mary. We have the name parameter and the health parameter, a double right here. So what we want to do is I'll just kind of show you guys what we can do with this functionality here, okay? So basically, let's set it equal to the reference of Mary. All right, so there we go. So now this pointer is pointing to the derived object of Mary. All right, so now let's try to go ahead and get the print info function out of Mary. All right, so we're going to use the character pointer, and we're going to use this syntax. You guys may or may not be familiar with it. It's kind of like using an arrow, and we're going to use the print info. All right, so now basically what this is doing is it is pointing to Mary and her implementation of print info, which will be obviously similar to this. However, it will include her HP and her name. So let's just kind of go ahead and show that really quick. This is kind of more so a review. We kind of covered something similar to this in a past video. So let's do compile the game.cpp and then execute. We get Mary 10. Perfect. So this is basically polymorphism. And what I mean by that is we are able to manage the derived object using a base object pointer. And this is just its functionality. I'll show you guys kind of some cooler ways that we can use it as well, especially if the functionality of print info is different, right? Which we will get into here in just a second with the attack features and all of that. So let's create the attack function. Okay, or I guess it might be better to go ahead and create this functionality up here. So yeah, let's go ahead and do this first. We'll do a take damage function. And this is more so just kind of a review of the virtual function and abstract classes. So let's go ahead and create a virtual function up here, take DMG, and we will pass in a double DMG. And we're going to have this not be a pure virtual function. We're going to have this just be for the base class character. So that way it's consistent with how it's supposed to be if we were just using like a character base class. So let's just have it where the HP will decrease depending on the amount of damage is invoked on the character. So pretty simple. So now let's do some overriding. All right, so we're going to go down here and we're going to do the void take DMG, and same thing. I'm going to do the double DMG. I'm going to add the override keyword here. And so I want the knight and the healer to take damage differently, because I guess knights are a little bit stronger, or they might have armor. A healer is a little bit weaker. They may not have as much armor on them. Whatever. Look at me trying to explain video games. So what we're going to do is we're going to reduce the amount of damage taken if it is a knight, and actually increase the amount of damage taken if it is a healer. So let's do double, let's do n. I'm bad at naming variables, and we'll do DMG -2. So if DMG is 10, the knight will take 8. All right. And let's do a little, let's do a little check here to make sure that it's not less than 0. Because if it is, then, you know, that's, I don't even want to know what happens. So let's just do, if n is less than 0, then we'll just set n equal to 0, just to avoid any sort of errors that may arise from that. Yeah, and then we'll just do the exact same thing. Now we'll just decrease the HP by the amount of n, because n will reflect the reduced amount of damage given to the knight here. So, and now let's kind of do a very similar thing down here. All right, so we're going to do the void, take DMG, send the double DMG, and then do the override keyword. And we're going to go down here, and I want them, or you know, I want the healer to actually take more damage. So we're going to do DMG plus 3. Why not? So sad day for healers, but anyways. So the healer will take more damage, and we'll do the exact same kind of functionality here. We will decrease the HP by whatever n ends up being. So if DMG is 10, then the healer is unlucky enough to take 13 hit points worth of damage. So this kind of just is a review of the abstraction tutorial that I did in my last video. So yeah, basically, you know, virtual function, and then these functions override it depending on the functionality we want in the derived class. It is important to keep in mind that we can actually still create an object of character, because this is not a pure virtual function. We are defining how damage is taken. So this technically can still be created into an object. During my last video, I went over abstraction. We created a pure virtual function, which looks like this actually. We need to set it equal to 0, and that is a pure virtual function. And this basically makes it where we are promising to provide the functionality in the derived classes instead of in the base class. But for you know, for this example, we're going to use it just as a normal virtual function, which just promises that, you know, like we do have this functionality here, right? But instead of using instead of redefining the function here, we are instead overriding the function, right? So now this decision of which functionality to execute is now made at runtime using the virtual keyword for the function instead of at compilation time. And if you don't understand, it's okay. I may go into a more detailed description in a later video about kind of how, you know, the dynamic binding and static binding works. So, but this is done doing dynamic binding, and it's one of the better methods, or, you know, the most ideal method for what we're trying to implement here. So yeah, let's just get back into polymorphism down here. So we now have the take damage function, the take damage methods in our objects. Okay, so now let's create another function really quick. Create an attack function, and this is going to be the polymorphism that you guys will see the most. And so this is very important. So we're going to just create attack character, right, as a function. And what the parameter is going to be, all right, is we're going to make the parameter a character reference. Okay, let's call it C. So a character reference. Okay, so that means that whatever is passed in here will be referring to a character object, right? So let's go ahead and add some functionality to it. And then I'll kind of show you guys more of an example. All right, so let's just have it where, or actually let's do, let's do print info first, actually. Do print info. That way we can see it before, you know, we could see their statistics before the damage was done, and then we can see it after. So let's do, take damage now. Take DMG, and we will do the damage at 5.1. So there we go. And then we'll do another print info at the end of it as well. So let's go and do that. And one more thing I do want to actually do really quick is I want to just create a character, character object. That way you guys can kind of see some of the functionality that I'm trying to represent here. So we'll just create a character named Harry and give this character 10.0 hit points. All right, so this is just a normal character object from the base class, and we can do this because our base class is not an abstract class, which would happen if there was a pure virtual function here. However, because it's just a normal virtual function, we are allowed to do this. All right, so now that I have these three guys, I want to kind of show you guys something really cool. We're going to get rid of this pointer for right now. We don't really need it at this current point. So what we're going to do is we are going to attack a character. Now, obviously, we need to pass in the reference of a character, so let's just do Harry. All right, and let's just make sure that this runs good and fine. That way we are not getting ahead of ourselves here and, you know, implementing more when something doesn't work. So we see Harry before the damage was taken and after. So looks like Harry took exactly 5.1 because it's just a normal character object, which just takes the damage without any sort of reduction or increase in damage. So just a normal character. Now, what happens if we add Mary or Cedric here, right? Well, let's add Mary here and just kind of see exactly what happens. And see what happens is Mary is having a very bad day. She is now at 1.9 hit points. That's terrible. But basically what I'm trying to showcase is the fact that we can pass in a derived object into this function, because this is using polymorphism. This is a polymorphism technique here. We can pass in the derived object into this function here because Mary is a character, right? Mary is indeed a character. And so therefore she is totally legitimate as a parameter for this kind of function. And of course, the same thing for Cedric. So, and I do want to showcase, I guess, how little Cedric will take compared to Mary here. Yeah, so Cedric still has 6.9 hit points there. So that's good. Good for Cedric. But yeah, this is just kind of showcasing how we can use polymorphism in a way that allows us to pass in derived objects into functions like this, right? So basically you can think of polymorphism like kind of as a way of allowing a reference, or sorry, a object reference or an object pointer to refer to a derived object, right? And this can be very, very useful for managing objects outside of certain scopes, and a lot of dynamic functionality that you can also implement in the future. So like this example here is us assigning different types of objects to the same reference type using this kind of function up here. So we went over the pointer, we went over the reference of how everything works. And yeah, now let's kind of get into some more practical examples of how this can be really cool and how we can use this for the future as well. So what I'm going to implement here is we are going to do one final thing for this video, and that is creating a party of these three people, these three characters, and then we're going to see them all get attacked in a for loop, essentially. So, and the way that we're going to do this is using a heterogeneous collection. Sorry, I always have trouble pronouncing that. But a heterogeneous collection. And basically what that means is it is a data structure of different data types, right? So clearly these are different object types, right? A knight is not a healer. A healer is not a knight. A character is neither of these, right? So what we want to do is we want to create a party of Mary and Cedric here, right? And we can do this using an array of character pointers. All right, so let's kind of demonstrate this really quick. So we're going to create an array of character pointers. We're going to name it party. going to have it just be 2 people. And in this array is going to be the reference of Mary and the reference of Cedric. All right, so we're going to do Mary, and then we're going to do, and then we're going to do Cedric. All right, perfect. Nope, not perfect. What did I do? Did I miss something? Oh, wait, do these go out in front? They do. Okay, cool. Sorry. Anyways, yeah, so the reference of Mary and the reference of Cedric. So this allows us to treat this array and do the same functionality onto the array, but of course, these derived objects will behave entirely depending on whatever their unique implementation is, right? So now let's go ahead and do a little for loop and attack these party members and see how they can handle certain damage. So let's actually do let's do a double EMG here, and let's replace this with the parameter. That way it's that way we can use it up here, or sorry, down here, and actually start doing some things. So let's see, what do we want to do? We want to do a cout, and let's just so that way we can see before attack and after attack. All right, so that way it's a little bit more organized for us. I'll do I'll just do the same thing down here, just for after the attack. So after attack, there we go. All right, and then what we're going to do is we're going to do a for loop, and we are going to showcase the statistics of both Mary and Cedric before the attack, and then we're going to do the exact same thing after the attack. So we're going to do int I, just basic for loop here, 2, and then I plus. Let's go ahead and implement this. So now we're going to iterate over party I, and then in order to, just kind of like how we did with the pointer, we need to use this little arrow here to do the print info function. Perfect. And then let me just go ahead and copy this really quick and bring it down here as well. All right, there we go. All right, so now let's actually, unfortunately attack these guys. All right, so let's do a for loop again, and we are going to use this for loop to attack both all of them, using the same functionality, just using the attack function, the attack character function. And of course, it will behave differently depending on which object the function is passing into it. So we'll do attack character, and then in the parameter, we will do the specific iteration. And then very important, make sure to dereference the pointer, because obviously we need to point to the object that is at that memory address. So just pointers, if you guys know how pointers work already. So there we go. And so now we should get a different result compared to the before attack and the after attack. And I'm just going to clean this up a little bit. All right, perfect. So, all right, so we have a party here of 2 people, Mary and Cedric. And then obviously we have them defined up here. And we are using this for loop and using this unique array of these derived objects, which are both character pointers, right? So now let's just go ahead and see what happens. And this is the type of stuff that gets me excited because, just having a tool like this in your arsenal for development, game development or whatever else is incredibly powerful. So, all right. So let's see here. What happened? Oh yeah, I'm still printing the info somewhere. Wait, why did it print twice? What happened? Oh yeah, okay, sorry. I forgot that we actually end up printing info inside of the attack character. I'm actually probably just gonna go ahead and take this out because, in attack character, all we wanted to do is just attack the character. So, my mistake. Let's go ahead and do that again. There we go. So, Mary and Cedric both have 10 before the attack, and then after the attack, Mary is struggling at 3.8, and Cedric is doing just fine at 8.8. So, perfect. So this kind of just gives you an idea for what polymorphism can be used for, and, once again, just think of it as allowing us to use object references and pointers to manage derived objects, right? Objects of different types. So this is very, very useful, and I could probably make a series just showcasing the amount of things that you can do with polymorphism. It's really kind of a difficult thing to go into in just one video, but you guys now have the main bits of information, the more important bits of information, and now you guys can also see kind of how inheritance and abstraction really kind of tie into it all. And so yeah, it's perfect. So if you guys have any sort of questions or anything else like that, let me know in the comments below or check the description. I'm going to leave some sources like I do in most of my videos for, if you guys are maybe looking for more information regarding this this kind of functionality. So definitely go and check that out if you guys would like to, or just let me know in the comments. And yeah, that's about it. So thank you guys so much for watching.